there are many places when we go later on into the concepts of trigonometry where we'll have an expression in our trig functions and we will want to factor it. Maybe we'll want to simplify rational expressions and they need to be factored, or solve trigonometric equations that are quadratic and we need to factor them. So in this segment, we are going to just practice factoring and looking at the expressions with the trig functions that are factorable and how we go about factoring them. So let's start off with our first one. It says to factor, and notice it's factor an expression. We're not solving an equation, so there's no equal sign involved in the original problem. We just want to factor this expression that's 2 sine squared t minus sine t minus 1. Now I know that it looks a little bit more intimidating because it's got trig functions in them, but here it's the sine of t that's squared, and then in the middle term there's just a sine t. So you can kind of think back in algebra, how would you factor 2a squared minus a minus 1? Like if you had an expression like that, how would you factor it? Well, looking at factoring this trinomial, it's in descending order, and I have a leading coefficient factor of 2, and my last constant factor is -1. So I want to see if there's a binomial product of 2 binomials where what goes in the first term has to multiply together to give you your first term, and then what goes in the last terms have to multiply together to get the last term, as well as the inners and outers giving my correct middle. Well, I don't have much choice on the 2a squared. It's going to have to be a 2a and an a to get 2a squared. And for the factors that multiply together to give me -1, it's going to have to be a -1 and a +1 multiplied together to give me that. So when I'm looking at it, how would I place these so that when I did the outers and the inners and combined like terms, I would get a -1 coefficient in the middle? Well, the negatives need to overrule. They need to be bigger so that it ends up with a -1 coefficient in the middle when I'm combining like terms. So whatever gets multiplied to the 2a needs to be my -1, and then what multiplies to the a needs to be my +1. So let's check. That'd be 2a times a, which is 2a squared. I'd have a -2a plus an a, which would give me a -a in the middle. And then +1 times -1 gives me my -1 last term. So that is a correct factorization when I think back with just the a in the replacement. Well, a is just taking the spot that sine t has in the original trig expression. So my factorization of this is going to be 2 sine t plus 1 times, a is the same as sine t, so sine t minus 1. So sometimes if we step back and look at it as an algebraic expression, factor it, we can go back to the trig expressions and put them in for the factorization. Okay, how about cosine squared t minus sine squared t, and I want to factor it? Well, here it's the square minus a square, so that's the difference of 2 squares. So let's remember what we had if we had a squared minus b squared, and we want to factor them. Here they're different. Cosine t is a different function than sine t. Well, the difference of 2 squares factors as my a plus b times the a minus b. A plays the role of cosine t, b is playing the role of sine t. So the factorization of my original trig expression will be cosine t plus sine t times cosine t minus sine t. Next up, 9 minus t tangent squared t. Well, this would be like 9 minus a squared. Again, 9 is a perfect square number, a squared is a square, and it's minus. So that's going to factor as 3 plus a times 3 minus a. But a is taking the place of tangent t. So I have 3 plus tangent t times 3 minus tangent t. And lastly, 4 sine squared t plus 5 sine t plus 1 Well, both of these terms have the sine function. It's squared in the first term, first power in the second term. So this would be like 4a squared plus 5a plus 1. It's quadratic. It has 3 terms. They're in descending order. I'm going to see if I can find my product of my binomials in order to factor these. Now 4a squared I can get by going 4a and a, or 2a and 2a. My 1 I can only get from positive 1 times positive 1 or negative 1 times negative 1. But I want a positive middle coefficient, so positive 1 and positive 1. The choices that would give me the correct 5 coefficient in the middle would be if I have a 4a and an a, and then a plus 1 and a plus 1. That'd be 4a squared plus 4a plus another a is plus 5a, and then 1 times 1 is 1. But a, again, is taking the place of sine t. So I'm going to have 4 sine t plus 1 times the sine of t plus 1 for my factorization. So that just gives you a look at how to just take and view each of these types of problems and how to factor them if you're asked to factor the trigonometric expression, or later on if I need to factor a trigonometric expression when I'm simplifying rational expressions or when I am solving a trig equation.